Good morning, colleagues. I extend a warm welcome back to the channel. If one has been experiencing a heightened perception of electrical activity in the atmosphere, this is indeed the case. This week, the sun has been exhibiting a notable increase in solar activity with a series of powerful solar flares illuminating our universe and setting the stage for some remarkable auroral displays. However, the question remains, what is occurring in the universe and why is this happening now? Let us proceed with a detailed analysis. First, we will discuss the most significant event that has generated considerable interest, an X-class solar flare that occurred just this Thursday. For those unacquainted with the intricacies of solar science, X-class flares represent the most powerful phenomenon in the solar system. Such events can be likened to the grand finales of a fireworks display, characterized by their immense scale, explosive nature, and unmistakable presence. This particular flare, classified as an X1.3, represents the lower end of the X-class scale. However, it should be noted that even at this level, the flare is of significant potency. It should be noted that this solar flare was not a brief and inconsequential occurrence. The flare originated from a sunspot region that had not yet been designated with a number. It is akin to a hitherto unidentified individual making a spectacular entrance at a social gathering. The flare reached its zenith at 5:43 a.m. Eastern Daylight Time, triggering seismic shifts throughout the solar system. When such flares occur, they can impact Earth's atmosphere, resulting in a transient yet perceptible decline in high-frequency radio transmissions. This phenomenon was recently observed, affecting communication networks across Africa, Europe, and parts of Asia. This illustrates the potential consequences of solar activity on global communication infrastructure. The question thus arises as to the causes of these powerful solar flares. The genesis of these phenomena can be traced back to sunspots. Sunspots are regions of the solar surface that are darker and cooler than the surrounding area. They are caused by intense magnetic activity. One may conceptualize these sunspots as cosmic stress points where magnetic fields become intertwined. When the magnetic energy within these regions reaches a critical point, it is released in the form of a solar flare. It can be likened to a giant cosmic rubber band suddenly snapping back into place. This flare was not the sole phenomenon to exhibit a fiery display. On the same day, two additional sunspot regions, designated as active regions 3811 and 3814, also contributed to the release of energy, resulting in the generation of M-class flares. These flares are classified as the second strongest after the X-class. While not as intense as X-class flares, M-class flares are still powerful enough to cause minor radio blackouts and have been observed to precede even larger solar events. In view of this solar activity, scientists at NOAA's Space Weather Prediction Center, SWPC, have initiated a program of close monitoring. One might inquire as to the significance of solar flares. When a flare occurs, it frequently results in the emission of a coronal mass ejection, CME. This phenomenon entails the propulsion of vast quantities of plasma and magnetic field lines from the sun into space. In the event that these CMEs are directed towards Earth, they are capable of traversing the vacuum of space at velocities reaching 1,800 miles per second. The effects of a coronal mass ejection, CME, can be observed several days after a solar flare, which is when the most significant phenomena occur. When a CME impacts the Earth's magnetic field, it can result in the onset of a geomagnetic storm. This is precisely what occurred this week. On Thursday morning at approximately 10:46 a.m. Eastern Daylight Time, the SWPC confirmed the occurrence of a G3-level geomagnetic storm. On a scale of G1 to G5, a G3 rating indicates a moderate level of geomagnetic activity, yet still capable of causing notable disruptions. However, the phenomenon of geomagnetic storms also has the capacity to ignite auroras, a development that is particularly thrilling for skywatchers. When charged particles from the sun collide with Earth's atmosphere, they interact with gases such as oxygen and nitrogen, resulting in their luminescence. The glowing particles that result from this interaction are responsible for the formation of the auroras, also known as the northern and southern lights. As a result of this recent geomagnetic disturbance, the probability of observing these luminous phenomena has markedly increased. Those residing in the northern United States as well as some upper Midwestern states, may be in for a particularly noteworthy occurrence this weekend. From Idaho to New York, the auroras may appear in a kaleidoscope of greens, pinks, and purples. However, the phenomenon is not merely a visual spectacle. It also offers insights into the scientific realm. These auroras are akin to a natural high-tech display, serving as a testament to the intricate and dynamic relationship between the sun and our planet. It is possible that the show may not yet be over. Forecasters are monitoring the sun with particular attention, having recently implemented a new geomagnetic storm watch for Friday. This suggests the potential for another G2 level event. What implications do these developments have for the general public? Should the conditions be favorable and the location appropriate, it is possible that another aurora display may be observed. Therefore, it is advisable to maintain a vigilant outlook and to be prepared with photographic equipment. As we continue to unravel the mysteries of our ever-active sun, we will examine in greater detail how these solar phenomena not only create beautiful light shows, but also affect our technology, from GPS systems to power grids. Furthermore, we will examine the methods by which scientists anticipate these occurrences and the insights they have gained regarding the sun's behavior as it approaches its solar maximum. Although solar flares and CMEs may appear to be phenomena occurring at a distance in the cosmos, their effects can manifest in unexpected ways. One of the more significant impacts of solar storms is their influence on our planet's infrastructure. The disruption of satellite signals, for instance, can have a considerable impact on a number of sectors, including television broadcasting, weather monitoring, and global communications. When solar particles interact with the Earth's magnetic field, they can interfere with satellite signals, causing disruptions. In extreme cases, such as the event observed in 2022, solar storms can even result in the loss of satellites from their intended orbit. Indeed, in February 2022, a solar storm caused by a coronal mass ejection, CME, disabled 40 Starlink satellites shortly after their launch. The increased drag from the geomagnetic storm prevented the satellites from reaching their intended orbits, resulting in their destruction in the atmosphere. This is merely one illustration of the unpredictable and formidable nature of these solar events, which have tangible ramifications for businesses, governments, and the general public. Moreover, the risk is not limited to satellites. Furthermore, solar storms have the potential to disrupt the functionality of power grids. In March 1989, a substantial geomagnetic storm initiated by a CME precipitated the collapse of the entire power grid in Quebec, Canada. A total of 6 million people were left without power for a period exceeding 9 hours. The question thus arises as to how this occurred. The geomagnetic storm induced electric currents in the ground, which resulted in the overloading of transformers and other electrical infrastructure. Subsequently, power companies have been engaged in rigorous efforts to safeguard their grids from analogous solar storms. Yet the risk persists. Another sector impacted by these meteorological events is the aviation industry. When solar particles penetrate the Earth's magnetic shield, they can result in an increase in radiation levels at high altitudes. Such circumstances may present a risk to passengers and crew on long-haul flights, particularly those traversing polar regions, where the Earth's magnetic field is comparatively weaker. To mitigate the effects of radiation exposure, airlines may occasionally alter flight paths during periods of heightened solar activity, resulting in longer flight times and increased fuel consumption. Furthermore, the use of GPS is susceptible to errors of several meters due to the influence of solar storms. This is due to the fact that GPS signals, which are transmitted from satellites to receivers on the ground, can be distorted by solar particles as they traverse the Earth's ionosphere. Such inaccuracies can have significant implications, particularly in domains such as aviation, marine navigation, and military operations, where precision is of paramount importance. Nevertheless, solar storms also present valuable opportunities for scientific research. They permit the study of the sun's behavior and facilitate a deeper comprehension of the impact of its activity on the entire solar system. Scientists employ a combination of ground-based observatories, satellites, and space probes to monitor solar activity in real time, thereby enabling the prediction of the occurrence and location of solar storms, which in turn allows for the preparation for their effects. The sun is currently approaching a period of heightened activity known as the solar maximum. This is part of the sun's 11-year cycle, during which the magnetic field becomes increasingly turbulent and the occurrence of sunspots, dark regions on the sun's surface, becomes more frequent. During this period, it is probable that there will be an increase in the occurrence of solar flares, coronal mass ejections, CMEs, and geomagnetic storms, in addition to heightened auroral activity. Furthermore, the solar maximum offers scientists a greater opportunity to conduct detailed studies of the sun. One of the most promising current missions is NASA's Parker Solar Probe. The spacecraft, which was launched in 2018, has been designed to achieve proximity to the sun, reaching a point closer to its surface than any previous spacecraft. The Parker probe is facilitating the acquisition of further knowledge regarding the sun's corona, which constitutes the outermost layer of its atmosphere, as well as the forces that drive solar wind and flares. Another mission that has attracted considerable attention is the European Space Agency's Solar Orbiter, which was launched in 2020. This probe is engaged in the study of the sun's poles, regions that have been largely unexplored until now. By observing the poles, scientists aspire to gain a deeper understanding of the sun's magnetic field and its influence on solar activity throughout the solar system. As we approach the solar maximum, it is of the utmost importance to monitor solar activity. For the time being, it is sufficient to simply acknowledge the aesthetic appeal of the auroras that may manifest in our skies this weekend. These remarkable displays serve as a testament to the immense power of the sun and its continued influence on life on Earth. Those fortunate enough to reside in an area where auroras are visible are encouraged to take advantage of the opportunity to observe this remarkable phenomenon. For those residing outside of the aforementioned regions, there is no cause for concern, as the sun will continue to exert its influence on our planet. We express our gratitude for your attention and encourage you to express your appreciation by clicking the like button and subscribing to our channel for further insights into the cosmos. As always, we advise you to maintain a keen interest in the universe, as it holds many intriguing phenomena.